So I was writing by coincidence of this book, and there's a 10-minute data modeling exercise to be found in the back of the chapter. It was fascinating to me, so I went back to this and looked. So it seems simple, but I was fascinated. Yeah. So inside of this chapter, you'll find this picture, and it says, list all the object classes, including their attributes and behavior, and the relationships between the classes that you can see in this picture would be appropriate for a city information system study. So we have 10 minutes. But remember that this will significantly impact the operation and transformations that you will perform since it starts. So we're looking at this. Well, we get an impression of the actual results. This is what they came up with. Apparently, a key challenge was that everything works from right to left. As you can see, everything looks like it's reversed. So I'm sure you thought of that when you were looking at that picture. But here's the real question. Why do two GIS&T users of equal creativity and intellect come to different conclusions about the same thing? What should be selected and what should be left out? Interesting question. That's the question that I'm asking myself here. Well, so the answer lies somewhere inside the imagination of the two GIS&T users. A data model is a set of constructs for describing and representing selected aspects of the real world in a computer. It's one easy definition. Well, the term data model is a little bit like grape nuts, the old Seinfeld joke. Grape nuts, you open it up, no grapes, no nuts. What's the story there? It's not a term that I use as a non-specialist. Take two general purpose nouns, put them together doesn't make any sense. Nonetheless, data modeling is both an art and a science. It's a little bit like realist painting. You take a style, a disciplinary perspective, create abstractions of real-world objects, and properties in an alternative medium. You take pride in those abstractions and the operations you can perform. So proprietary GIS software, open source software, there's no hidden message here. I don't have any prejudices about this. Indeed, GIS Analyst desktop client created a possible range of attribute values, and the GI Volunteers mobile client, where attribute values are more strictly enforced. Same idea. But back to the original question, why would two GIS&T users of equal creativity and intellect come to different conclusions about the same thing? So I guess the answer is we don't really know. Somewhere in this sequence of work we call data modeling. So over the past 4 years, right here on campus, we've been experimenting with something else. We call this sustainable systems modeling. And it's a little bit different. It's a combination of three things: systems concepts, data models, and work deliverables. So there's a compilation of at least 60 reports. Our hypothesis, working hypothesis, is that people, all things being equal, were able to come to a better conclusion than if they had used conventional data modeling. So in comparing the two, lots of text here, but let's just say there's not much difference here with the two definitions. Not much different. Geographic data modeling on the left, sustainable systems modeling on the right. A little bit of difference lies in the fact that what is your domain of relationship, your relationship domains. In data modeling, typically it's one domain, the biophysical human built environment, in one scale. Sustainable systems modeling, it's 3 domains and 3 scales. That's a somewhat major dimension of difference. And finally, also somewhat different. On the right, sustainable systems model is a set of systems concepts for describing, assessing, and managing a complex social ecological system. That's for describing and representing selected aspects. And finally, last but not least, very different, right? The goal is to measure states, alternative states of a complex social ecological system, and putting an adjective in front of the word state: sustainable, existing, alternative, future, resilient, or resistant. So, back to our example. How many of you started by selecting people as an agent object class? Good job, yes. 0. People are the first agent object class actually that I would have selected. So yes, we're different. You still have time to raise your hand. Oh. That's it, thank you.